Good evening. Okay, now we are next seeing one more problem on internal energy changes. So the problem reads, a sample of solid copper is heated beyond its melting point. The graph shows the variation of temperature with time. Okay, cursor visible. Right, okay. The graph shows the variation of temperature with time, during which stage is R, there is an increase in the internal energy of the copper. So shown here is a graph, P to Q, Q to R, P to Q, Q to R, and so on. Now towards it, this graph is clearly interpretable. See here, there's a change in temperature. There is no change in temperature. There's a change in temperature. First time when we look at this graph, if you already studied about latent heat and specific heat, you know that, okay, so here might be the solid was at a temperature T1, and then from here, you went until T2. So the solid then got transited to liquid. So maybe this is also once again at T2 here. So I can say P was at the solid phase. P was at the solid phase. Q was at the liquid phase. And R was at the gaseous phase. Simple. Okay, R is not in gaseous phase, sorry. Okay, so liquid phase. And here, after it reaches the temperature T2, the temperature of the liquid copper is increased. That's what we can say. Okay, very easy. So therefore, now from here, what we understand is there is one temperature change, there's other temperature change. Okay, so therefore, there are two temperature changes. One happens at P, other happens at Q. One happens at P, the other happens at R. Okay, Q, there is no temperature change. The moment we read this question, the first thing that comes to our mind is that, see, when there is a temperature change, there's an internal energy change. If there's no temperature change, definitely no internal energy change. That's what we think, right? So therefore, I have seen this question answered by many students saying that C is the right answer. But unfortunately, C is not the right answer. Can you guess which one is it? It is P, R, and Q. Here also there is an internal energy change. So the right option is actually A. Okay, it's not C. Now you can ask me, say, how is this at Q? Okay, there's a change in internal energy. Now, what is internal energy? The energy of the molecules, okay, which is present either in the solid or in the liquid. During solid, what happens? Okay, when you are giving some temperature, the molecules in the solid starts moving randomly and it starts vibrating randomly. And as a result of it, when you increase beyond a certain value, there's a possibility that the bonds between any two molecules break. And as a result of this, so they start becoming liquefied. Okay, they start becoming liquid. And there are liquid molecules. When all the bonds break up, okay, when you supply more and more energy, so at that time, all the bonds in the solid starts breaking up. And hence, it becomes liquid. And when it becomes a liquid, now what happens? There is some energy which you are supplying, right? See here, what is that you are doing? You are supplying energy to change the temperature of the solid. When you go beyond that melting point, then suddenly the solid gets converted to liquid. Now, when the solid is getting converted to liquid, what is the process happening? There's a bond between any two atoms. This bond has been broken down, which means you need some energy to break those bonds also, right? So therefore, you are giving some energy. That means the liquid is getting some energy. Where is that energy stored? It's called as internal energy once again, right? So therefore, there is an internal energy used here also. Okay. See, remember, internal energy is being consumed in every process. Okay, whether it is solid to solid, solid to liquid, liquid to gas, whatever it is the energy of the object that is increasing. When the energy of the object increases, two things can happen. What can happen? One is temperature can change. Temperature can rise. Temperature can rise. What is the next thing that can happen? It can give rise to change of state. Change of state. Change of state. Right? So therefore, both the things are happening over here. And hence you see internal energy is utilized here, internal energy is utilized here, internal energy is utilized here also. At all the three places, internal energy has been used. Okay. But what doesn't change? So here temperature changes, here temperature changes. Okay, this could be T3 here. But whenever a solid becomes a liquid, there is no change in temperature. That is something definitely happens. Okay. So as a result of this, okay, internal energy change has been observed everywhere. Remember this, internal energy change is observed everywhere, but the temperature changes only during a solid to solid, and between a phase transition, there is no temperature change. So therefore, don't get confused. So many students, what they do is they confuse the internal energy with the temperature. And casually would have been told you in the class also that internal energy increases or temperature increases. But you should ask the question, is it that the internal energy will increase only when there's an increase in temperature? Or does the internal energy increase even, okay, when we get solid to liquid phase? So the answer is, it does increase when there's a phase transition also. Thus the correct answer is option D. Hope this video helped you. If you like this video, do like, share, and subscribe to my channel to get more updates of this site. And also, students, do let me know what kind of problems would you like to solve more. Okay, so I get an idea and I would like to do only such kinds of problems. It would also be better if you can send me those problems. Okay, how do you send these problems? That's one question. Maybe I'll do one thing in every video. I'll just put my email ID so that you can send the problems to me, and as much as possible, I will try to solve it across and put it across as a video. Right? It would also be a service to the learning community, and it will also help me out. How does this video help me? Two ways. The first one is I take tuitions. It will help me there. And secondly, the YouTube likes will increase. I can monetize it. And lastly, very important, this could contribute only to 10%. But the last 80% is it enhances my knowledge. It can help me to figure out where do the students make a mistake, right? Okay, so let me stop here. My email ID, I can just give it to you. It is rathankar@gmail.com. You can reach me out here so that I can help you out with more number of questions. Thank you. Thank you, friends, for watching this.